Hello friends, today I'll discuss about busbar protection relay for single bus system. In this picture, there exist four substations: substation A, substation B, substation C and substation D. Substation A is connected via source and substation D is also connected via source, that is generator. And in between substation A and B, and there exists one double circuit line, and between substation B and C there exists one double circuit line, and between C and D there exists one single circuit line. Now consider there exists no busbar protection relay at substation B end and fault occur at the main bus of the substation B end. Due to fault at main bus of the substation B end, the remote end substation, that is substation A and substation C end, the line distance relay will pick up and clear the fault at zone 2 time, that is at about 300 to 350 millisecond time delay the fault will be cleared. Now since the fault is cleared within 300 to 350 millisecond, within this time severe damage may occur for the main bus system and equipment depending upon the fault current. If the fault current is huge, depending on the fault level of the substation B end, then bus damage or equipment damage may occur at substation B end. And that is why the busbar protection relay is used in order to detect and clear the fault instantaneously if fault occur at the main bus system of the substation. Now there are two types of busbar differential relay exist. One is high impedance type and another is low impedance type. First I will discuss about the high impedance type busbar protection relay for single bus system. For ease of understanding, only 3 feeder is considered in a single bus system. The criteria for high impedance type busbar protection relay are in the primary side, P1 of all the cities shall be connected towards the bus side and P2 shall be connected towards the line side for feeder and towards the transformer side for transformer, and all the CT ratios shall be same. If the feeder CT ratio is 1000/1, then transformer CT ratio shall also be 1000/1. Again, in the secondary side, all the S1 terminal of all the cities are connected together to connect one end of the relay, and all the S2 terminal of the all the cities are connected together to connect another end of the relay as shown in this diagram to form the busbar protection relay. This is the basic principle and basic criteria for busbar protection relay. Busbar protection relay operate on the basis of Kirchhoff's current law or KCL. As per KCL, for a single bus system, as there are 3 feeder, the current is flowing to the direction of the bus side for feeder 1 and feeder 2, and current is leaving from the bus for feeder 3. That is, feeder 3 is the outgoing feeder and feeder 1 and feeder 2 are the incomer for the bus. So as per KCL, the total incoming current is equal to total outgoing current, that is I feeder 1 plus I feeder 2 is equal to I feeder 3. Now we know that for a CT, if the current is flowing from the P1 to P2 direction in the primary side, the direction of the current in the secondary side shall be from S2 to S1 direction. Again, if the current is flows from the P2 to P1 direction in the primary side, the direction of the current in the secondary side shall be from S1 to S2 direction. So the direction of the current in the primary and secondary side has been shown in the relay. Now since in the primary side I feeder 1 plus I feeder 2 is equal to I feeder 3, as the current 2 current is flowing towards the bus, in the secondary side the 2 current, that is for feeder 1 and feeder 2, is from the direction from S1 to S2 direction. But for feeder 3, as the direction of the current from P1 to P2 direction, and in the secondary side from S2 to S1, the secondary current for feeder 3 is equal to secondary current of the sum of the feeder 1 and feeder 2 current, and that is why the relay current is equal to 0. So under normal condition there exists no current in the relay, and that is why relay maintain a stable condition under normal operation. For ease of understanding, let us consider that feeder 1 and feeder 2 are the incomer feeder, and the current flows to the bus is 100 ampere each, and feeder 3 is the outgoing feeder, and the current is flowing from the bus to the feeder 3 is 200 ampere. In case of feeder 1 and feeder 2, since current is flowing from P2 to P1 direction in the primary side, the current will flow in the secondary side of the CT will be from S1 to S2 direction, and the magnitude of the current shall be 1 ampere each, as the CT ratio is 100 by 1 for all these three feeders. So 1 ampere for feeder 1 and 1 ampere for feeder 2 is flowing from S1 to S2 direction in the secondary side of the CT. Again, for feeder 3, since current is flowing from P1 to P2 direction from 200 ampere, therefore in the secondary side the current flowing from the S2 to S1 direction, the magnitude of the current is 2 ampere. So as the 2 ampere current flows from S2 to S1 direction, which is equal and opposite to that of the sum of the feeder 1 and feeder 2 CT secondary current, and that is why the relay current is 0. So under normal condition relay will not operate or maintain stable condition. Now consider if fault occur at point F at main bus of the bus bar, then the direction of the current in the feeder 3 will reverse. That is, for feeder 1 and feeder 2 the current is flowing from P2 to P1 as I1, I2 respectively, and for feeder 3 it will also be P2 to P1 and the magnitude of the current is I3 respectively, and the secondary current of this replica of the primary is small I1, small I2 and small I3 respectively for feeder 1, feeder 2 and feeder 3. So small I1 current is flowing from S1 to S2 direction, and small I2 current is flowing from S1 to S2 direction for feeder 2, and small I3 current is flowing from S1 to S2 direction. So all the three current flowing from same direction, and that is why the relay current is the sum of these three current, and that is why relay will operate and send a trip signal to the all the circuit breaker associated with the bus to isolate the faulty system. Now why high impedance busbar differential relay? Because resistance Rs is used in series with this busbar relay, and that is why it is called high impedance type busbar protection relay. Now why resistance is used in series with the busbar protection relay? Now consider a through fault occur, that is fault occur outside zone of the busbar, that is fault occur in the feeder 3, and due to this fault and CT saturate for feeder 3, and that is why there will be a mismatch of the current in the relay, and due to this mismatch the relay may operate under through fault condition. So in order to prevent relay to operate under through fault condition due to CT saturation of any feeder or any transformer, a high impedance resistance is used in series with this busbar protection relay, and that is why it is called high impedance type busbar protection relay. Since high impedance is used in series with this busbar protection relay during through fault condition, high voltage develop due to resistance is used in series with this busbar protection, and this if this high voltage is greater than 2 kV, then in general a metro seal is used in parallel with the resistance and relay as shown in this diagram. Now in case of power system, that is with two feeder, that is two incomer and two outgoing feeder and one transformer, the busbar protection relay connection high impedance type has been shown in this diagram. that is the CT, all the CT ratios shall be same, and P1 and P2, P1 is connected towards the bus side for substation B, and P2 is connected towards the line side for feeder, and for transformer it is transformer side, and all the S1 terminal is connected to connect one end of the relay, and all the S2 terminal is connected to connect another end of the relay. A stabilizing resistance is used in series with this relay, and also a metrocell is used in parallel with the resistance and relay combination as shown in this diagram.